This is Advanced Algebra Lesson 8.5, Products with Radicals, and the big idea of this lesson is that the product of the nth roots of non-negative numbers is the nth root of the product of the numbers. So before we get started, I'd like to just recall your some information that we learned in some previous lessons, that the square root of a times b was the same as the square root of a times the square root of b. And basically this is an extension of the power of product postulate, because this could be the same as a times b raised to the 1/2 power, which is the same as a to the 1/2 times b to the 1/2. So now if we think about it like that, we go to the root of a product theorem, and it says for any non-negative real numbers x and y and any integer n greater than or equal to 2, then we can say that xy raised to the power of 1 over n is the same as x to the 1 over n times y to the 1 over n powers. Or we can go in radical form. The nth root of xy is the same as the nth root of x times the nth root of y. So I'd like to have you try this example, and I'd like you to do it actually without your calculator. The third root of 320 times the third root of 25. We could say that that is the third root of 320 times 25, and that is the third root of 8,000, and we know that the third root of 8,000 is 20. Let's look at another example. We're going to once again assume that x is greater than or equal to 0, and we're going to perform the multiplication of the fifth root of 8 times x squared times the fifth root of 4x to the 8th. So the way we're going to approach that is that this could equal the fifth root of 32 times the 10th root of x. So we know that the fifth root of 32 is 2, and the fifth root of x to the 10 is x to the second. We're going to look at the fifth root of 96y to the 11th. Now when we look at this, it's not going to be a perfect, clean answer here. Not everything is going to be able to come out from under the radical. So what I want to do is I want to break things up under the radical into groups of fifths. So, or numbers that are going to be perfect fifth roots. So if I think about 96, and if I could think about different numbers that are factors of 96, I know that 32 times 3 makes 96. And I know that the fifth root of 32 is 2. So I'm going to keep 32 times 3 under there. And now if I look at y to the 11th, y to the fifth root doesn't come out nice and even with that, but it does with y to the 10th. So if I make this y to the 10th times y to the first, I now have the equivalent of y to the 11th, but it's in things that are going to come out nicely with the fifth root. So the fifth root of 32 is 2, and the fifth root of y to the 10th is y squared. So that leaves me with 2y squared times the fifth root of 3y. So that's one way to simplify our radicals. I would like you to try examples 4, 5, 9, and 12. And when we come to class next time, we will discuss those, and we will even do a few more of these examples. This concludes lesson 8.5.